All right, trying again. This is Spritely Goblins, a distributed journey. I am Christopher Lemmer-Webber. Um, I am here to talk about Spritely, which is a distributed social networking system. I'm especially in this talk going to talk about some of the elements relating to kind of the programming language history and some stuff that I think is relevant for ideas kind of coordinated with Spritely that I think are relevant to the Guile and Guix communities and how they can kind of help advance this whole space. Um, what Spritely is trying to do is to build distributed social networks that have more advanced privacy and security features, all the way up to building distributed virtual worlds. But that kind of requires a lot of different components. You can see some of the character artwork that by David Revoix that represents the different pieces we're trying to do within Spritely that accomplish those goals. But we're going to mostly focus in this talk on Spritely Goblins. So, what is Spritely Goblins? It's a distributed programming environment following the classic actor model. It has quasi-functional state management, which is kind of elegant in the sense that an actor, it basically has a current behavior in response to some message, and it's able to use the become operator to specify what its behavior will be for in response to the next message. And that turns out to be completely sufficient for all kinds of state management things and also enables some other really powerful things, such as easy transactions. If something goes bad during the middle of what we call a that turn, which is really kind of the top level handling of an event from the event loop, um, we can actually just throw away the entire set of changes that were happening within that turn. That makes it easy to have really simple, highly localized transactionality. And it also allows such things as time travel. Since actors are really a mapping of some sort of reference to current state, you can just kind of snapshot them and travel back and forth in time across whatever the mappings of references to behaviors are. And that's really nice. And it also follows the object capability security paradigm, which I will be talking about quite a bit in this talk. Um, so before we get any further, though, I'm going to break the fourth wall here a little bit. Instead of just presenting as the normal kind of slideshowy approach, I'm going to instead end up kind of going through some browser tabs, and that's partly because I am very tired. There is a lot of stuff happening in the world, as I'm sure you all know if you're watching this at the start of 2021. And there's just a lot of things going on that make things exhausting, but it's also just partly that we're doing a lot of work, and I'm doing a lot of work in terms of getting the components ready. And one of these major components you're looking at right here is a diagram of the captp system, which I'll be talking about a little bit more, which allows for the distributed programming system to work very easily. But part of the thing that happened when I was working on this talk is I kind of couldn't decide which pieces I wanted to talk about, especially because I wanted to talk to the Guile and Geeks community kind of specifically about some things I thought were really important. So I made the anti-pattern mistake of deciding to do almost everything. And so now instead, I am giving a talk that maybe more resembles kind of an everything bagel, right? It's got a little bit of this, a little bit of that, and that's just how it's going to be. So let's kind of go through things. If you've seen some of my talks in the minimalist programming languages room that I'm currently presenting in at FOSDEM, maybe you've seen, over the last few years, I've talked about some things that might seem very similar, right? So a few years ago, I presented on Async, which is also an actor model system that I was building on top of GNU Guile. And it's got this code at the top, and here's a link to one of the talks I gave at FOSDEM, and you can watch it. There's the FOSDEM edition right down here where it's glowing. And if you watch that talk, what was really cool about it and got the audience really excited, I think, was that I was basically showing off how to. The presentation itself was a little textual virtual world where the participants in the audience were actually walking around the rooms and interacting in it. And this was pretty cool, and I think gave the impression that things were really far along. And I think I did figure out some interesting things in that for that demo, but there's a lot that was also missing. There were a lot of things we couldn't do. Right. So, especially one of the things that I demonstrated during the talk was me actually changing the world that people were in response to them asking me questions. And then one of the big questions I kept getting asked was, can we start changing the world? And the answer was no, I didn't really know a secure way to do that without people being able to basically pwn my machine. But it was something I was very interested in. And that has partly brought me down the route of exploring the object capability security stuff that I'll be talking about more in this talk. Um, I also gave a talk, I guess, about 2 years ago, I think, and on this talk that probably has gotten more attention than any talk I've ever given otherwise, called "The Guiler's Year of Racket." And in some ways, it's kind of unfortunate that it's the most attention I've probably gotten in a talk because I think it might also have been very misunderstood, and that's probably my fault. Right. So the talk was really meant to show off kind of the cool things I was seeing inside of the Racket world and hopefully kind of inspire the Guile world to kind of explore and pick some of that up and also encourage some level of cross pollination. But I think maybe what I ended up doing instead was giving the impression that Guile is a past, Racket is a future, and that's really not what I meant. And if you've seen, I've continued throwing patches at geeks and stuff since then, and I still love the Guile community. And a lot of this talk will be about what I think and hope we can do, um, bridging Spritely with the Guile community, and the ways that geeks can take similar ideas to kind of lead the way forward. So I think Guile is really important and has a large and important role to play. So this is the Spritely website. You can kind of scroll through it and you'll see this talk up here near the top gives kind of an overview at a very high level about all of the core ideas inside of Spritely. And then you can scroll down through this and see kind of all the different pieces I showed the icons for earlier. But even if you're more interested in the goblin side of things, there's a nice talk on here that you can watch, which actually shows me um, showing off how to extend a game that I'll be showing in a moment live. And kind of shows really what it looks like to program in goblins. And I've decided to strip that out of this particular talk, even though I will be talking about some programming language history, because I think there's some other more pressing things to talk about with this community. Nonetheless, maybe you take a look at this and you got really excited and you say, oh gosh, this is all scheme. But then you go and look at the documentation, and if you're a Giler, maybe it's a little bit sad because you're like, oh, well, but this is all done in Racket, right? And you may wonder, like, well, I mean, if Racket and Guile are both more or less schemes, how hard would it be to port between them? How hard would it be to bring goblins to Guile? And the answer is, I don't think it would be very hard. And in fact, I plan to do that, hopefully this year. And part of the goal in doing that would be being not only hopefully opening some things up to the Guile world, I think, maybe that's a bit of hubris there, but also I think that we could, there's some cool stuff that we'll be able to show off if we have both a Racket and a Guile implementation. I'll get to that in a moment. Um, but anyway, I've tried to take a demo-centric approach in Spritely, and basically what that means is that every time I start doing something inside of one of the Spritely components, I try to write some sort of demo that shows off how cool the ideas are that I'm talking about. Because I think people sometimes have a hard time conceptualizing things when they just hear about it with a lot of words, right? So this is probably the demo that got the most amount of attention. I wrote this little space shooter video game that runs in your terminal called Terminal Phase. And, of course, I got people excited because, it combines two very kind of 80s, 90s aesthetic things, I guess. But also, um, you keep seeing that I'm doing this time travel thing inside of this animated GIF, right? And that's basically what I was talking about earlier. If the player, if something bad happens, they can basically, if you turn it on with the time travel flag, you can move back and forward in snapshots in time. But what's more interesting about this is that I wrote the time travel, the entire game, without even thinking about the time travel demo, without even thinking about it being an option. And then just as kind of an afterthought, I was like, oh, right, well, we already have the right pieces to do this time travel stuff because I already support the ability to snapshot things. So, really, in just a couple of hours after the game was already written, I just threw in some code and the time travel just worked. Right. So it's exciting when you have something like that and the right abstractions are already there. Um, but I think despite not being as shiny, this blog post and what it was showing off was more important. Here you see a person launching, well, it's actually supposed to simulate two people talking, and they're talking here over Tor Onion services, specifically using the captp protocol. And Goblins has this idea of captp. The idea is that the security model of Goblins is basically all about whether or not you have object references. And also, programming entirely happens over either immediate call return messages to these actors, or asynchronous message passing with promise resolution. And it turns out you can just, if it's in the latter camp of doing asynchronous message passing, it doesn't really matter where the actors live. And I wrote, kind of exciting the same way that they kind of in parallel with the terminal phase time travel thing, I actually wrote this whole chat program without testing to see whether or not it would work over the network. And then I just wrote some code to hook it up to the captp stuff, connected these two things over captp, and it just worked, right? And the whole chat protocol, it even includes a certain amount of authentication in it, and that whole thing is written within 250 lines of code. That's the whole client and server protocol. And the GUI was only another 300 lines of code. So I think that that's pretty cool. I think it's pretty cool that the whole quote unquote protocol really just felt like writing normal code. And I think that that's the as cool as the time travel stuff is to show off, this is the bigger deal about Goblins, and the thing that I think is really going to open up a lot of possibilities in terms of building distributed social network things. Um, so let's go back to that presentation. So we're going to resume uh, traversing through the fourth wall, and we're going to look structurally at what Goblins is. So here you see two machines, machine one, machine two. Okay, they're connected together so they can talk to each other, right? And within machine one, you see this thing called VAT A and VAT B. And within machine two, you see VAT C. What's a VAT? So a VAT is just a OCAP type world term for a specific kind of event loop that contains a certain number of objects in it. And so, for example, you can see that VAT A contains the objects or actors Alice and Alfred within it. VAT B contains the object Bob within it, and VAT C contains Carol and Carlos. Um, Now, what's also interesting is that Alice has a reference to Alfred, and Alice has a reference to Bob. Now, Bob has a reference to Carol, and Carlos has a reference to Bob. But even if machine 2 is misbehaving and conspires so that it gives Carlos access to, or I should say, Carol access to Bob when it was only supposed to be Carlos having access, um, nothing about this allows machine 2 to have access to Alice and Alfred, which you can see none of the arrows from machine 2 are pointing at. So this allows us to only hand out over the network the references we would like to hand out. And basically that's the abstraction layers. There's also this thing called an actor map, which handles the whole transactional blah, 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 but not really too important for this talk. So I'm going to give kind of a very fast overview of the ideas of, or really I should say kind of programming language history and math language history that led to Goblins today. So in the 1930s, we have the development of the lambda calculus. In the late 1950s, we have the introduction of Lisp. We got the world's greatest syntax out of it on accident. In the 1970s, we got Smalltalk and also actors appearing around the same time. And Smalltalk was still kind of more synchronous call return, but was able to be, in some ways, also an inspiration for the work that was happening on actors to enable this vision of asynchronous message passing for distributed objects. And later in the 70s, we have the scheme programming language, which, of course, if you love Racket or you love Guile, you will already know, right? And the scheme programming language had a lot of interesting development about it, but one of the interesting and curious parts about it is it partly came out of Guy L. Steele and Gerald Sussman trying to understand actors. And they kind of came to the conclusion, oh, these are mostly the same thing, right? This idea of and send are pretty much equivalent to each other. And this idea of the customers that Carl Hewitt was doing was pretty equivalent to this thing that they called continuations. And there was this kind of back and forth about, are they the same or aren't they the same? I'm going to talk about how they're a little bit different in a moment, but Joule is probably a really interesting programming language in the way that it took the actor model very, very, very seriously. And it also introduced the same promise system that Goblins uses, including the notion of promise pipelining, which turns out to be very valuable. And in later in the 90s, some of the same people who worked on Joule also worked on the E programming language, actually as kind of an accident due to a contract dispute between two organizations. The E programming language ended up coming out and accidentally developed many interesting ideas and kind of the distinction that we'll be talking about in a moment. So, the classic actor model, according to Carl Hewitt and Company, and I say classic because Carl Hewitt has some new ideas about what actors might be that are maybe some things that are not just in this list. But I would like to focus on kind of the core, well studied list of actor fundamentals. So, following that, the idea is that in the classic actor model, in response to a message, an actor can send messages, or you could also say invoke other objects, basically, right? And in Goblins, we can use the arrow operator, which is equivalent to send, you could say, or the dollar operator, which is equivalent to an actor specific version of apply. Um, and also, in response to a message, an actor can choose to create other actors, in which case it would also get a reference to that actor it created. In Goblins, we use a spawn operator to do this. An actor can also designate its next behavior, and this turns out to be, as I said, completely sufficient to do all state management things you could possibly want to do. And in Goblins, we use the become operator. And, not according to Carl Hewitt would not like if I say this, but it turns out that become thing composes very nicely with lambdas. Um, I don't think Carl would like that, but it's a really nice connection. But the confusing thing here maybe is why do we have two of these operators here? In fact, for the most part, I think this is where the confusion about kind of the distinction between what the scheme folks were doing and the actor folks were doing comes in. Send versus apply. What are the differences? So, to understand that a bit further, we can notice that some of these things really focused on the synchronous call return worldview. So we have, the lambda calculus, which did that. I mean, you could also argue it really didn't have state changes. So, yeah, we're kind of ducking it a bit there. But the Lisp world also definitely had it. Smalltalk definitely had it. Scheme definitely took that perspective, and E kind of took that perspective. We'll evaluate that kind of in a moment. And if you're familiar with the call return worldview of the synchronous call return worldview, yeah, I mean, I'm sure you're familiar with it because it's how most programmers program. And we have some sort of notion of a heap. We basically call it the actor map in Goblins. And you've got some notion of a stack, and you know the drill, right? You invoke something, and it puts some sort of message on the stack, which invokes another thing, which puts some sort of other message. And that star on the right hand side, you can imagine pointing at one of these objects in the heap. And we call another thing, and it does something else. It goes up, the stack grows, and then it shrinks, and then it might grow again, and then it shrinks, and then eventually it terminates in a value, right? Very familiar. And maybe some state changes happen in between, depending on who you want to fight with. Um, but in the eventual send worldview, this is kind of the worldview of actors and the Joule world, and also kind of E. So in this worldview, instead of having a stack, you have some notion of a queue. And that queue may be entirely actor local, or it may be within some event loop. But for our perspective, we're not going to pay attention for that in this slide. So we just notice that we've got some messages queued up for these various objects, right? These various actors. And one of them is going to get popped off to the left, so that the queue shrinks, right, and gets sent to one of these objects. And then we might pop off another one. It handles that, and then this one actually, while handling it, queues another thing to be held it, and then that pops on to that gets pushed onto the queue, and then that gets handled, and then so on and so forth, right? So that's kind of and that's very inboxy, et cetera, et cetera, et cetera. So the hybrid worldview, as I said, was kind of an accident. And my understanding is that Electric Communities Habitat and the folks working on Joule, there was some sort of contract snafu, and basically what happened was that the E programming language was kind of developed in a rush, and in the process managed to come up with something very interesting. And Goblins takes that very interesting idea and takes it very seriously. So this idea is what we call the VAT model. And what you can see here is it's got both things, right? Kind of if we just look on the upper half of this, it looks like the synchronous call return thing where it's got some sort of stack. But it's also got this thing at the bottom, which is the queue for the event loop territory. And the idea here is that in order to operate on this stack, what we're going to do is we're going to take something off the queue and we're going to handle it and we're going to push it onto the stack, right, to deal with it, right? And that thing is then able to call, if it wants to, do synchronous calls to other actors who are within the same vat, but only synchronous calls to actors which are within the same vat. And if it does so, it's going to do the same kind of stack growing and shrinking thing. Um, but then we'll handle the next one, and it might grow. And oh, look, this one actually puts something on the queue. Now, this is just the perspective of looking at one vat. Now, it's also possible to send messages that end up going onto other vats. Oh, by the way, you might have noticed, I'm going to move back a couple steps, doop, doop, doop. Moving forward, you'll notice that this message to the right-hand side kind of got queued to be put on the queue. So this idea of doing one of these kind of going up the stack and down the stack things is called a turn in the kind of VAT using OCAP community. And the thing that's happening, the reason why it's on the right hand side is that just the same way that changes don't happen to the actor map as in terms of they're not committed until the transaction is not committed until after the turn completes, lest it throw an exception, in which case whatever promise is related to that turn would be broken, and any message handlers would be informed, but the state would be changes would be reverted. We also don't want to send messages that actors were saying they'd like to send unless if that's actually intentional, like unless if everything goes through. So if something goes badly during the middle of it, we're going to actually throw that away. But in this case, it did go fine, so that went on the queue, right? And so the VAT model combines both of these worlds. It does a synchronous call return world of apply in Goblin's dollar, and the eventual send world of send, in Goblin's arrow, right? And both of these provide some interesting and different properties. In the call return world, these things are really restricted to the same VAT. But the eventual send world view, it doesn't matter where the actors are. You can send them anywhere. But in the call return worldview, you get the response is what we call immediate, right? Once the operation and the execution is done, it will return to what we call its continuation, and whatever code is following it will be able to move ahead sequentially, right? And in the actor worldview, it's going to, especially actors plus promises, I should say, because the original actor model didn't necessarily have promises. So this is kind of more of a Joule and the E world version of actors. The eventual sends are going to be eventual, so we don't know when they're going to be resolved, right? You send something, and that actor could choose, it could end up handling about 10 other messages before it's going to get to yours. You don't know when it's going to happen. But in the call return worldview, you get return values, but the eventual send world, or at least this particular version of it, has promises. So you can listen and set up callbacks for when things complete. In the call return worldview, we have something called so actually, I should say, let me correct myself. This last line on here is what these two different worldviews give us. So the synchronous sequential call return worldview of apply, when combined with the VAT model, what it gives us is easy, straight ahead code, but also transactions, right? And that's really powerful. Highly localized transactions that are very simple. You can build transactions out of distributed components, but it's complicated. But you get really easy transactions locally. And with the eventual send operator, you can do distributed programming without deadlocks. And that's really important, right? Deadlocks, the bane of distributed programming everywhere. So it turns out it's really great to have both of these things. It's not the case that the actor and scheme world were doing exactly the same thing. They were doing very similar things. And it's not the case that one of them is superior to the other, in my perspective and kind of the VAT perspective. It's that they both provide something valuable. And understanding what each valuable component is allows us to take advantage of the whole thing. So Fantasy is building the distributed virtual world side of this whole thing, and that again, probably sounds very out there, right? Like that's super ambitious. Well, you already saw me do a text-based virtual world in the Async demo, so I don't think it's that hard. And this has actually already been done because the E programming language actually came out of Electric Community's Habitat, which was trying to build distributed virtual worlds in the late 90s, died in the dot-com crash, but instead we got the E programming language, the most interesting programming language you've never heard of. So, um, this also all relies for its security mechanism on something called object capability security. Here you see Alice has a reference to Bob, Alice has a reference to Carol. Um, Start in the initial conditions, actually moving back right here. Bob does not have a reference to Alice, and Carol does not have a reference to Alice, and Bob and Carol do not have references to each other. If Alice wants to give Bob access to Carol, Alice can send Bob a message with Carol as an argument. Now, if you're thinking in scheme land, you can think Alice invokes the Bob procedure or whatever, or some Bob method on, your Goops thing or whatever, and passes in Carol as an argument, right? And that gives Bob access to Carol, right? And that change in what is available also requires a certain amount of change in time. But we have done nice transactional, quasi-functional ways of managing that within Goblins. And it turns out this whole recognition that, oh my gosh, the security model really does seem to resemble just argument passing was made by Jonathan Rees. And thank you, Andy Wingo, for pointing me to this paper. It definitely changed my life. The idea here is that what's within your lexical scope is your authority, right? And that is your authority model. And it turns out this whole access control list and blah, 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 that stuff's just meching up your entire design. Lexical scope not is the answer. Dynamic scope, the world of ambience and ambient authority and stuff like that, and Unix style access control lists, that's what's making us sick. So, now going back to this diagram, we can see that machine 1 is connected to machine 2, but there's this weird stuff in the middle. What the heck is that, right? Well, it's time to break the fourth wall again. So, here is where captp comes in, and this is a thing that I showed on that board diagram. Yes, Mark Miller, I know one of the trapezoids is backwards. So here we see VAT A is connected to VAT B. It's the whole Alice has a connection to Bob, Alice has a connection to Carol thing, and what you see here in the middle was me trying to work out some of the details about how this complicated thing called handoffs, it's not too important to this conversation, works. But what's really cool is that if you see that Alice having a reference to Bob, you see it going through this E thing on the right-hand side, and that is the export table. And it's imported pairwise on the I side in VAT A, also at 3. So capability references between machines, or VATs or whatever, are very, very efficient from the captp model. They're very, very, very simple, because they're just pairwise integers. Now, if you want to do the handoffs, that's where things get more complicated in the middle. But this is delightfully simple. And you could also imagine, well, what if that upper left-hand machine was a Racket program, but the upper right-hand upper right-hand machine was a Guile program? What if they could both speak captp? Well, then we wouldn't have to decide whether or not we were going to settle on Guile or Racket, because if they could both speak captp, they could actually just talk to each other just fine. So what about the bottom one? Can we do something different with that? Sure. Well, what if we decided to make it JavaScript or something like that? And indeed, the Agoric folks, as I'll talk about in a moment, are doing just that. But I'm getting ahead of myself. Again, I said this is going to be kind of an everything bagel. I have gone from the world of talking about Goblins as design. Now I want to talk more about what I see the future is between the world of Guile and the world of Guix, and how we can kind of bridge with the work that I'm talking about and the ideas I'm talking about. So as I said, things as they're currently done within Spritely are done within the Racket programming language. But we could port Guile to, port Goblins to Guile. And what might that give us? Well, you could imagine that if we had Spritely being built on top of, if we had Goblins on top of Guile, Well, there are a whole bunch of really useful things within Geeks and within the Guile world, which you could do in that case. You could spin out a cluster of Geek servers that could all talk to each other over captp really easily and very securely. And so this, I think, is a really exciting opportunity. Um, but again, let's talk about the JavaScript side of things. So as I said, my friends over at Agoric, who are doing amazing work at the very moment, and are a lot of the people who worked on E and so on, and I've just, basically stolen as many ideas from them as I can. They are doing work that's more focused on smart contracts and blockchainy, cryptocurrency type things. But what they're also doing is building all of these similar kind of layers to what you're seeing I'm talking about. Well, not all of them. Many of the similar layers, at least the distributed programming layer, and they're helping the JavaScript world have access to that. And in fact, um, there is a open issue here where we are talking about, can we get our captp implementations to talk to each other? And as you can see, there's lots of conversation. Um, Turn on my scroll wheel, go faster. Yeah, so um, we're pretty optimistic that we can make this happen. And therefore, if we write these nice backend things that are in Guile or whatever, and we're like, well, we got to get this stuff, we need clients that work in the browser, we don't have to solve that problem in the sense that we can use Agoric's JavaScripty stuff. But something that's interesting about Geeks is how much we tend to care about reproducibility and buildability, or sorry, bootstrapability. And the Mace project is a great example of just how seriously we take this, as in terms of trying to have reproducibility all the way down, right? Um, and unfortunately, the JavaScript world has not been that great comparatively. There was a blog post I wrote about half a decade ago talking about how difficult it was to package jQuery for geeks, and things have, despite some work being done, not really gotten better. Now, another path out is maybe the Guile world could just say, well, you know what, screw it, we're going to compile to WebAssembly, right? And then we can just skip all those problems. But I'd like to emphasize that the problem is less JavaScript than it is the JavaScript packaging ecosystem with NPM and so on. My conversations with the folks at Agoric is that they don't want to be dependent on NPM, so maybe we don't have to worry about that long term. Nonetheless, to use any interesting JavaScript tooling at present, you have to tie into that ecosystem that has made packaging reproducible, buildable web applications that are free software so nightmarishly difficult for us. Um, but maybe you'll say, well, the fact that we're doing reproducibility and bootstrapability and that we're compiling everything from source means that we are in the best position of security possible because everything's free and open source software, therefore secure. Well, here is an interesting article written by Kate Sills of Agoric, talking about how the principle of least authority, which really means don't hand out more authority than you need to, which basically is OCAPs, would have prevented the event stream incident. And if you're not familiar with the event stream library fiasco, it's that maintainership got handed over to another developer who then inserted malware. And what's being said here is that actually that malware, if we had taken an OCAP approach, wouldn't have been able to do anything particularly dangerous. And what's also interesting is that you could argue that this event stream vulnerability may have been completely free and open source software. It's not necessary for it to have been so malicious for it to have been proprietary software. It could have been a free software virus, right? And in fact, vulnerabilities like this have been inserted in the past. They're at least in one well-known case. In 2003-ish, it was discovered that the kernel.org mailing list had been broken into, and that the CVS repository had gotten changed to insert this vulnerability to give somebody externally root access to anybody who was running the Linux kernel at that version. Now, my understanding is that we're lucky that this got discovered because both because of the revision control system, but also because the server intrusion was discovered. But if somebody actually sent a patch that was in some sort of package, would we actually notice if they inserted that vulnerability? Well, my sense is no. And actually, there's pretty good reasons to believe this. This dissertation is a great example right now. Building reliable voting machine software by Ka-Ping Yi. And especially the section where they built a minimalist programming language for the election software, got some of the best programming language and security people in computer science around to investigate it, inserted an easy, medium, and hard bug. The easy bugs were very hard to find, the medium ones extremely hard to find, and not everyone found them, and the hard bugs were not discovered by anybody. And this was within, I think, just like 110 lines of code, or yeah, about 100 line region of code, to have these three vulnerabilities inserted. And these are some of the best security people in the world. So things being free and open source software is not sufficient security. When the whole actor model versus scheme stuff was being figured out, Guile, Steele, and Gerald Sussman published some very interesting papers, which are known as the Lambda papers. Lambda, the ultimate imperative. Lambda, the ultimate declarative. Blah, blah, blah. Well, I like to think Jonathan Rees's security kernel based on the Lambda calculus is an honorary Lambda paper, Lambda, the ultimate security model. And to really understand this a bit better, let's think about why is solitaire so dangerous on my computer? Solitaire can crypto locker my computer. It can steal all my Dogecoins. It can, make commits maliciously as me and convince people that I inserted them, and all sorts of things like that. It's solitaire. Why should it be able to do that? Imagine instead if you opened, let's just imagine solitaire as a scheme procedure, but we perfectly sandboxed it. So we perfectly sandbox it using, Guile's sandbox module or whatever, and it can't do anything interesting. It can't even open a window on the screen. Well, that's not great because we actually want it to display to the screen. So maybe outside of the sandbox, we actually have a procedure that is privileged to be able to make screens with canvases. And we hand that to the solitaire procedure. Now, the solitaire procedure is able to display to the screen and receive keyboard and mouse input, but only when this window is active. It can't damage my file system, it can't talk to the network, but maybe I'd like it to write to a specific high scores file. Well, we could create a file descriptor that is to a specific file and pass that into the solitaire procedure, and now you can see how just using lexical scope and argument passing, which we're already familiar with, we have the right model to keep things secure. Now, it turns out the same idea can apply to operating systems, and Gnode is an example of something that's trying to explore that today. Sandstorm is another fairly recent example that's gotten some amount of resurgence that's been mostly focused on web applications. And actually, curiously about it, the Cap and Proto protocol, which was used for it, especially and some other things, actually is secretly a quasi implementation of captp, hence part of the pun of the name. Um, but I think the Geeks community could actually do quite a lot here. And so, how could we bring object capability security from an operating system level? Well, if we think about instead of wrapping things on the function level, which allows us to have language level security, we could do it on the process level. And that would allow us to have operating system level security rather than language level security. And it turns out if we start with our operating system booting up with access to the disks and blah, 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 and we want to start handing out authority, well, we're in a better position to do this than most because we actually are currently maintaining our own init system. And that's a great place to start handing out authority. And hey, I think nobody's at a point where they're saying GNU Shepard's so perfect and beautiful that we're not willing to change it. So another way in which we can move forward on this is that the herd is currently being explored within Geeks, and actually the mock ports approach is one way that you could do capabilities. However, there are other approaches, such as the SEL4 microkernel, which has much stronger security audits and actually mathematical proofs attached to it. I'm not saying that we need to go this route. I'm saying let's keep our options open and be willing to explore multiple paths, especially because it's very exciting that herd is a new and open possibility, but it's taken a while, and there may be other worthwhile approaches to take as well. And so another way that we could end up looking at the ways that things have been secured in the past, Polaris did an interesting job of this in Windows XP, where they actually just created separate users for each program that was being run. And they had a concept called a powerbox, which is kind of like when in your browser you say, I'm going to upload this file, and you select a specific file. Well, that web page doesn't normally have access to the file until you actually select it through that file open dialog, which is in fact a kind of powerbox. So we can do things so that also programs at runtime, not just when they're booted up, can get access to things as they go. And there are more ideas here like Plash and Shill and stuff like that that have explored some of these ideas. Gosh, I really wish that the Linux kernel got Capsicum. Um, and here's an interesting project to try to do a minimal sandboxing and containerization type project. But, actually, Ludovic just recently posted some example code on how we might be able to do our own simple containerization thing ourselves. I don't see any reason why this has to be Geek specific, but it would be great for it to be written in Guile so that geeks can compose very easily with it. Finally, if you find these ideas really interesting, we put out a podcast called Hygiene for a Computing Pandemic on FOSS and Crafts. Has lots of references on it. And I'm basically out of time, so now I just want to say, let's end on a moment of optimism. I like this picture because you can see the networks that people have built when the lights have gone off. Effectively, the sun is pointing away from the earth, and the lights that humans have built have been made. We're already doing a lot to network things. Can we allow our users to be networked and secure? And just also secure in general. The geeks world takes doing things the right way very seriously and is probably about as well positioned as anybody possibly can be to do things very well. I look forward to working with the Guile and Guix community and hope that we can manage to bring things in a very exciting and future facing direction so that users can be safe and free on their computers. Thank you very much.